Tesla tried to stamp this exact steel, the machine lost. Here's the question nobody in the automotive world actually wanted to answer. Why build a car body out of a material conventional factories literally cannot shape? The answer tells us everything about why Tesla exists. This isn't just a truck. It's a manufacturing problem nobody had ever solved, built into a shape nobody asked for, using a material that almost broke the company trying to use it. This is the story of 30X steel. By the end of this explainer, the way you look at every vehicle on the road will be permanently different. Steel is iron. Specifically, it's iron with a small amount of carbon locked into its crystal structure. The more carbon you add, the harder the steel gets. But harder steel is also more brittle. It wants to crack, not bend. For 100 years, car manufacturers have lived inside a very specific, comfortable compromise zone. Soft enough to stamp and weld at high speed, but hard enough to pass a crash test. Standard automotive steel sits right around 270 megapascals of tensile strength. That's the baseline. That's what every Toyota, BMW, and Ford is built with. But Tesla's 30X steel sits at 1,800 megapascals. We're not talking about an incremental improvement here. This is a completely different category of material. 1,800. This number represents a true paradigm shift in metallurgy. It's a material so unyielding, it completely rejects the very foundation of modern automotive assembly lines. Here's the hidden problem Tesla ran into, the one they didn't mention until it almost sank the entire project. When you run standard automotive steel through a stamping press, it bends, holds the shape, and you move on. But 30X cold-rolled stainless has something called springback. Springback means the metal doesn't fully accept the new shape you gave it. It remembers where it came from, it wants to snap back. And the harder the steel, the worse that springback gets. Tesla tried using conventional stamping dies on this material. Those dies wore out in days. The panels completely failed to hold tolerances. The geometry was off by millimeters, which, on a highly angular truck like this, is glaringly visible from across a parking lot. This is exactly why the Cybertruck looks the way it does. The angular design wasn't just an aesthetic choice. It's an engineering compromise born directly out of material reality. You simply cannot deep draw ultra-hard stainless steel into compound curves the way you stamp regular car doors. A compound curve requires the steel to stretch in two directions simultaneously. At this extreme hardness level, 30X steel will literally crack before it cooperates. Instead of fighting the material, Tesla completely designed around it. Flat panels, single-axis bends, sharp angles. The design itself is the solution to the metallurgy problem. That isn't a hack. That's absolutely brilliant engineering. Let's examine what 30X actually means, because the marketing doesn't tell the whole story. Tesla calls it ultra-hard 30X cold-rolled stainless steel. The 30X refers to the 300 series stainless steel family, specifically a variant very close to 31 stainless, sitting right in the austenitic stainless category. Austenitic stainless features a face-centered cubic crystal structure, delivering fantastic corrosion resistance and decent ductility at room temperature. But Tesla's specific variant has been cold-worked, meaning it was rolled and compressed at room temperature, never heated first. Cold working does something deeply interesting to that crystal structure. It introduces microscopic dislocations. Think of these as tiny defects packed into the lattice that physically block any further deformation. The more dislocations you pack in, the harder the steel gets. It absolutely refuses to move. You need drastically more energy to deform it. This process is called work hardening, and Tesla pushed it further than any automotive manufacturer in history. Pushing work hardening to this extreme creates a steel panel capable of stopping a 9mm handgun round without penetrating. It absorbs dents and dings that would instantly crumple conventional car doors. It doesn't rust, it doesn't corrode, it doesn't even need paint for protection. A conventional car is soft steel with a protective layer on top. A Cybertruck panel is the protection itself. That's a fundamentally different manufacturing philosophy. There are major trade-offs, though. Here's what the spec sheets don't tell you. Ultra-hard stainless at this exact thickness has almost zero resistance to large area flex deformation. In plain language, you can dent it with a bullet, but you can also leave a handprint wave just by applying steady palm pressure. We call this the material paradox. It's harder than anything else on the road, yet fully susceptible to a cosmetic deformation called oil canning, a surface-level waviness visible under light that doesn't affect structural integrity, but drastically alters how the truck looks. This waviness isn't a defect, it's just physics. Any flat panel made of thin, hard material spanning a massive area without curvature to add rigidity is inherently going to flex. To solve this, Tesla implemented 3 elegant engineering workarounds. First, interior bracing. Second, highly controlled panel sizing. And third, utilizing the heavy battery pack itself as a core structural element of the vehicle. This perfectly illustrates how they engineered the exoskeleton body to be significantly stiffer than it looks, fully compensating for the physics of large flat panels. This is a stark reminder that every single materials choice is a trade-off. 30X steel is no different. Tesla didn't just pick a hard steel. They picked a steel that forced them to completely rebuild their manufacturing logic from scratch. No traditional stamping presses, no traditional paint shop because unpainted stainless doesn't need one. No body-in-white construction in the conventional sense because the exoskeleton itself is the structure. Look at how this cascades into a massive advantage. The final result is a vehicle built with fewer body parts than any mainstream truck on the market. Fewer parts naturally means fewer welds. Fewer welds directly translates to fewer failure points. And fewer failure points means you are looking at much higher long-term durability. That's the core engineering argument for why this exact material, despite every single manufacturing headache, was ultimately worth the fight. You're looking at an entire material philosophy, not just a vehicle. Every car manufacturer on Earth spent decades heavily optimizing inside the exact same comfortable, narrow window of stampable steel. Tesla stepped completely outside that comfortable window, enduring years of significant production pain just to build the brand new processes required to make it work. The question isn't whether 30X steel is perfect. It isn't. No material is. The real question is whether the extreme trade-offs, the massive manufacturing complexity, the oil canning, and the relentless springback problems are actually worth what you get in return. A truck that doesn't rust, a truck that takes a bullet, a truck whose very body serves as its own armor. That isn't just a truck. That's a completely different answer to the question of what a vehicle can be. If a sheet of stainless steel can force an entire global industry to rethink its assembly lines, what other impossible materials are just waiting to be forged?